Alright, so we're back for lecture 13B, Engineering 270. So let's dig deeper into some of the further mechanics of this indirect file access system. So we've been working with INDF0, FSR0H, and FSR0. Well, I'm going to keep thinking about FSR0 as being just a single register, but keep in mind it's actually a composite of two 8-bit registers. So INDF0 basically says, look at the value contained in FSR0, use that as the address of my operand. Well, there's some variations on INDF0 that are available also. For example, there's POSTINC 0. And it also has a mysterious footnote, this is not a physical register. Well, what does POSTINC do for us? It does this. It's very common that after we use this indirectly accessed file register, that we're going to want to increment FSR0. It's a very common thing when we're marching through memory and we want to do something with successive locations. So instead of doing something with INDF0 and then saying increment file select register 0, if we simply access POSTINC 0, it does both of those things for us. It uses the value currently pointed to by FSR0, and then it goes ahead and increments. And that's useful because we can't say increment file register FSR0. There is no register called FSR0. There's only H and L. And we could increment FSR0L, but you know, if we do that, we have to make sure it doesn't overflow. And if it does, then we have to also increment FSR0H. In other words, when we go from 0x00FF and we increment, we want to end up with 0x0100. So if we increment the low part and it rolls over, we have to increment the high. Too much work, right? So by using this POSTINC 0, our loop here, which was 3 statements, becomes 2 statements. In this case, it would just be add WF POSTINC 0. That has to be uppercase, sorry, it's case sensitive. So add WF POSTINC 0. That adds the contents the register pointed to by FSR0 to W, stores the result in W, and does the increment. And now we could just say if FSR0L is not equal to 26, go to loop. And our loop is right here. So this not only makes our code a little bit shorter, but it also cleans up this detail of how to increment this file select register. Okay, there's also a POSTDEC 0. Same thing, except after we use INDF0, it subtracts 1 from FSR0. And there's a PREINC, which says before you use FSR0 to access a file register, add 1 to it. So increment and then use the new value of FSR0 to access a location. And there's also this plus W0. And plus W0 is interesting. This register says, read the contents of FSR0, read the contents of the W register, add them together, use that as the address that you're after. And this is useful because, for example, well, let's write some code here. Suppose we wanted to clear some file registers. Suppose we wanted to say clear file registers from location 8 to location 2. Okay, so we want to clear out file registers 2, 3, 4, 5, 6, 7, and 8. Well, here's one way I could do this. I could say copy x2 into file select register 0. And that's got to be high and low. And now I'm going to say move LW6. And now I'm going to make the following loop. And here I'll stick with actual assembly language to show you how easy it is with this plus W0 instruction. So I'm going to say clear file register plus W0. Okay, what's that going to do? It's going to take the contents of file register 0, which is 2. It's going to add W to it, which is 6. That gives me 8. It's going to clear file register 8. And now I'm going to say subtract 1 from W. So I'm going to add literal value -1, that's hex FF, to the W register. So I'm going to subtract 1 from W, which means W is not going to be equal to 5. And I'm going to say branch if it's not 0, back to loop. I'm off by 1, my bad, but work with me for the basic idea. We're going to subtract 1 from W, and if it's not 0, we're going to come back here. Well, W is now 5, so we're going to clear the file register pointed to by FSR0, which is 2 plus W5, that's file register 7 gets cleared. We bring W down to 6, we go back up here, it's going to clear file register pointed to by X2 plus the next value of W, and each time we do this, it's going to access a location at a lower and lower address. Okay, so what are we doing here? We're basically treating FSR0 as the starting address of an array, and we're using the W register as an index. And like I say, this is off by 1. I should have started with a 1, because this one would actually branch when W equals 0. But that's just an edge case detail. So the central concept here is that we're using FSR0 as some initial address, and we're using W to say how much do we want to move from that initial address. And it could be positive or negative, right? But typically we use this if we're accessing an array, or if you've looked at data structures, if you're accessing a data structure where you know where some collection of data starts in memory, and you just want to take offsets from that location to access other pieces. Alright, so those are the essential elements of this. Now, if you're familiar with C, let's look at what this means in C. INDF 0 is basically the thing pointed to by FSR 0. So we're using this as the address of an operand. INDF 0 basically says, let's look at the thing pointed to by FSR 0. POSTINC 0 is basically star. FSR 0 plus plus. Which means look at the address, look at the thing pointed to by FSR 0, and when you're done looking at it, increment FSR 0. Okay, post dec 0 is basically the same thing, but we decrement FSR 0 after we're done. And PREINC 0 is saying first increment FSR 0 and then use that as the address of an operand. And this one can be a little tricky, but plus W0 is basically looking at, if we assume everything is 8 bits byte oriented, take the contents of FSR0, add the contents of W, use that as a pointer to the actual operand that we want. So that's how this would translate into C if you're comfortable and happy with the language of pointers and addresses in C. Alright, so just a few more details. There's actually 3 sets of indirect registers. We've been talking about INDF 0, POSTDEC 0, FSR 0H, and so on. There's an exact same set that end with a 1. Indirect file register 1, POSTINC 1, PREINC 1, plus W1, FSR 1, H, and L. And there's another set that ends with a 2. So we have 3 complete identical copies of registers that we can use for this indirect addressing. And this is extremely useful. For example, if you wanted to copy a set of contents from one set of file registers to another, you could set up one file select register to point to the beginning of that first block, put another file select register to point to the beginning of the second block, and then just start doing move FFs if we want, right, or move through W's. Copy from INDF 0 to INDF 1, and then if we somehow increment FSR0 and FSR1, we're going to end up moving data from one block of memory to another. And of course we could use POSTINC 0 instead of INDF 0 and take care of the automatic increment of FSR0 and so on. Okay, so the last mechanic I want to mention in here, this does involve an actual instruction. This is the load file select register instruction. And this is one of these weird two-word instructions, so a total of 32 bits for LFSR. And LFSR takes two operands. The first is the number of the file register you're after. This is a 0, a 1, or a 2, so it's coded in 2 bits. And the second operand is a 12-bit number, which is just written down as 12Ks. So how does this work? Well, over here, for example, we wanted to set file select register 0 to be, let's say, 30. Well, one way to do that is, so let's write some code. Set file select register 0 equal to 30. So here's one way to do this. Move the literal 30 into W. Move W into file select register 0 low. And then move a 0 into W. And move W into file select register 0 high. And this will work for any value we want to put in FSR0. Basically, we're just loading that value of the low byte into W, put that into the low byte, load the high byte into W, put that into the high byte of FSR. But we do this enough that there's a separate instruction which lets us do this more succinctly, and it would look like this. Load file select register 0, 0x30. And that basically does this. And this can be a 12-bit number. So this is perfectly legal. Load file select register 0, 0xF25. And that will load 25 into FSR0L and 0F into FSR0H. And so this is a convenience that not only takes fewer instructions, but it makes it clearer what's going on in your code. It makes it a little less prone to errors. Alright, so we will work through a gazillion or more homework problems on the board, playing around with indirect addressing using this file select mechanics.